In this final video on section 4.1, I want to talk about something called generic classes. And we'll revisit this in section 4.2, but I want to at least give you a little bit of exposure to it. A generic class is something that can parameterize a type. Now, we've actually seen these before, and we talked about them before with generic methods. But now we're actually going to write a class that is itself generic. Okay? So what is that class? Let's suppose that we want to create a pair of objects of some types T and U. Okay? So by a pair, I mean we just want to associate two values with each other in some pair. Okay? So maybe we might create like a new pair of, let's say, I don't know, like an integer and then another then some like a string. Okay? Maybe we can do like a new pair and then maybe like a point, like 3, 4, and then maybe the second is, I don't know, it could be anything. So like maybe just the sum of their coordinate values. I don't know. It doesn't matter. The whole point, no pun intended, is that we are going to make this class generic so it can work over any type. So how do we do that? Well, when we first talked about generics, we said that we have to add these things called type parameters to the method header. And indeed, we need to do that again, but we also need to do it here when we're talking about classes. Okay? So what we're going to do, we're going to say that this class has some types T and U. So this class will use two types T and U. Okay? And it's going to store two values, one of type T that is the first thing in the pair, and then it's going to store something that is of type U that is the second thing in the pair. Okay? So we're going to call these first and second because the first and second thing is in the pair. And we're going to have a constructor that we will pass to it the first thing and the second thing. Okay? So then we'll just assign them over like this. And when you have the pair, you should not and you cannot put the type specifiers after the constructor. You just need the constructor name, and that's it. Okay? So let's create some examples of this. Okay? Well, actually, let's think about what kind of functionality we want this to have. Well, we probably want some way of getting the first and the second thing in the pair. Okay? So we'll say, let's create the method to call, let's create the accessors. We'll call them get first and get second. Okay? And we'll actually spell it out. So like get first, get second. Okay? Now, what are the return types of these methods? Well, of course, like even if these were any other thing, like integer or point or string or whatever, we would put that. But here we can put T, or we need to put T get first, and then return something, and then U get second, return something. Okay? So what do you think we're going to put here? Well, of course, we only have one thing we can put, and that's first. And then here we only have one thing we can put, and that's second. Okay? But there might be some other things we want to do with this. So let's say we want to do three things. We want to determine whether two pairs are equal. So of course that will require us to override this method. And for now we'll just say it returns false. Let's say that we want to convert it into some string representation. And then let's say we want to get the hash code of some pair. Okay? And again, we'll just return nothing for now to make sure that we can write test cases. Okay? So let's create these tests. Okay? So test.equals, test2string, test hash code. So one thing I'll also introduce to you is this notion of something called at before each. So what we could do is create a bunch of pairs, like pair, integer, string, P1 equals new pair, then pass 42, 42. Then maybe have another pair like point, integer, P2 equals new pair, new point, 3, 4, 7, pair, maybe like, I don't know, a list of integer, and then maybe a boolean, P3 equals new pair. We don't need the types here. And then maybe like list out of 43, -1, 0, 4, false. Okay? So we could do this for all three of these methods, and then like copy this here, copy it here, test each of the three methods. But that's redundant for obvious reasons, right? So what we can do instead is declare these as instance variables of the pair class. So we can say private final pair integer string p1, and we'll just copy this for all three and change the types to what we want. So pair of integer string, pair of point integer, and then pair of list integer boolean. So we're just testing it with random types. It doesn't really matter. But now, actually, no, sorry, these cannot be final. And I'll show you why. But the main thing here is we want to do something. We want to instantiate all of these variables, all of these instance variables, before running each of these tests. Okay? So how do we do that? Well, we can write a method that's called init. Now, it doesn't have to be called init, but we'll just call it that because it's going to setup. Sometimes it's called setup. In fact, let's call it that. So this will instantiate all of the instance variables that we want to use in each of these tests. And what it will do is it will call this method before each of these methods. Okay? And basically each one will have sort of a clean slate, so to speak. So it will call this method each time before it calls each of these test methods. So we're going to say this.p1 equals new pair, and we'll say that it's equal to this. And I'll just copy it. We'll say that p2 is equal to this. We'll say that p3 is equal to this. Okay? Now, in p1, or inside of equals toString and hash code, we can write some assertions like this.p1 should probably be equal to new pair 42, 42, the strings. And it should, so p1 should not be equal to p2 because they don't share the same values. Assert equals, let's see, what's wrong with this? Yeah, okay, that's fine. Assert equals maybe this dot p3. We'll just create a new pair like this. Or rather, let's make one of the fields not equal. So we'll say assert not equals, and we'll say this is true. And then we'll do it again, except we'll just change one of the elements to show you how this will work. Okay? And then for toString, well, we have to think about a representation of, so actually these should be reversed, sorry about that. Well, I mean, it doesn't really matter, but for consistency, we'll just flip them. I mean, here it really doesn't matter, but if we're saying that, if you want to test the values of P3, or P1 through P3, and those are the actual values, we should say what the expected values are. Okay? So, and the same thing is true for here. So, but we need to come up with some representation for pairs. So how do we want to do that? Again, there's no real answer for this, but I'm going to say, let's take all things and then put them inside of these less than signs, and then we'll put the first thing, a comma, and then no space, and then we'll put the second thing. Okay? So like if we had a point here, it'd be like parenthesis, x equals 3, y equals 4, and there should be a space there. an obvious space at least. So this would be a pair whose first thing is 42, whose second thing is a point where the x is 3 and the y is 4. Okay, so in this case here, we're going to say p1.toString, and let's just create two strings for all three of these just to show you what's really going on here. So it's going to be equal to, let's see, we'll say, I'll just add this for all of these. We'll say this, and then 42, 42. So in this case, it's actually a little bit ambiguous, and it really can show what can happen or what might go wrong when you're outputting things as strings. So the issue here is that we have a type whose first thing is a number and whose second thing is a string. But when we convert them into a string, the quotes actually get dropped. So it looks like there's just two integers here. There are ways around that, and I'll let you think about how you might fix that. Okay? So fix it meaning that there might be a problem, but there's not, I mean, there is an issue here, but it's not like the end of the world. Okay? The second thing is a point and an integer. So the point would be 3, 4, and sorry, there wouldn't be a space here. And then I think the value was 7. And then for this case, sorry, no space again. The third thing here, we have a list where its elements are 43, -1, 0, 4. Then we have a space and then false. Okay. Now what about the hash code? So we'll just test one of these in that case, but let's create a set of pairs. Now we'll say that, let's say that we want to create a set of pairs whose things are integers and strings. Okay, so we'll say that we have a set of pairs of integers and strings, and let's add a new pair of, let's say 42 and the string 42. And then we'll say the string 43, then maybe the integer 43, and then something like that. I don't know. And then let's add something that's duplicated. So the question is, how many elements are in this set? Well, we have 1, 2, 3, 4, 5, but this one's obviously a duplicate, so we'd think it would be 4, but it is indeed going to be 5. Okay? So let's add this assertion to be, this should be 4, so s dot size. Of course, that's going to fail, and all three of these are going to fail because we haven't done anything yet. Okay, so how do we determine if two things are equal? Well, actually, let's do the two-string representation first, because this one has some pretty big nuances with it. Okay, so what do we do? Well, what do we say? We just said return, then the opening and closing, so we'll just add those first. Now, we're going to say plus something. So what do we want to do? We want to get the string representation of first and second. And how do we do that? Well, we can just do first.toString. Okay? And then we'll say plus the quote, and then plus this .second.toString, and then plus the right opening, or the greater than sign, and then we're done. Okay? That's actually it. That's really all it is to it. Okay? So, let's see. Expected. So let's see. Did I test that wrong? Oh, I wrote the test wrong. Yes. So x equals 3, y equals 4. So, now it works. Very good. Okay? And then let's do the hash code one. Let's do equals first, sorry. Because hash code, we need dot equals to do hash code. Okay? So, how do we check to see if two things are of the same type? Well, we probably, again, we need something like if it's not the case, instance of pair. Okay? So we can do this, and this works fine. But there's sort of an issue with the fact that this is a generic class. Now, remember, generics are a compile time thing. They don't exist at runtime. So we need some way of saying that if this is not a class, or O is not an instance of something that can be interpreted as any type at all, then return false. So the way to do that is to use the correct way to do that is to use these things called wildcard characters. So we're saying if O is not an instance of a pair where the two types are anything at all, then return false. Okay? But if it is a pair of some types, then we can specify that, or we can use that. So the problem here is if we try to say T and U, then that information, the T and the U, go away at runtime. So what we can do is say, well, we know that O can be some type of object or some type of pair, and we can cast it safely like this. Now, do we know whether these two types, like for example, if we tried to say, like for example, if we were to compare, these two things, what would happen if we did something like assert not equals new pair 42, 42? Okay, obviously these are not equal because this is an integer, whereas P1 has it uses integers and strings in its pair. Okay, so what Java will do, remember that Java, the dot equals method should always have an instance of check. So we can just use or leverage the dot equals methods of first and second. So really all we have to do is do return this dot first, dot equals other pair dot first, and this dot second dot equals other pair dot second. Okay, that's all we have to do. Because if these two types are not the same, rather, if this dot first's type is not the same as other pair dot first's type, or the same case without loss of generality for the second, then it will be caught by the first check. So, for example, in comparing an integer against a string, in the integers dot equals method, it would say if the object that we're giving is not an instance of a string, or an integer, sorry, then we're going to return false, because there's no way they can be equal. Okay, so let's do, let's run it now, and now everything actually runs, but this is, so actually wait, why does this work? Oh, it's because I'm stupid. It's because, let's see, so, actually wait, no, this one shouldn't even be in here. Let's do 40. Okay, now, okay, yeah, okay, there we go. So, yeah, so this should be 4 because we have a non-duplicate, 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 and a duplicate. Okay, so how do we fix that? Well, we can just get the hash codes of this dot first and this dot second. Okay, so if we run it now it should work. It doesn't work. Why did that not work? Let me look into this. No, it's because I'm just an idiot. So this is not, when I said this was a duplicate, this is not a duplicate of this because this number's not the same. So change this to 42, and now it perfectly matches this one. So we can run it, and all tests pass. Okay? Very nice. So in this video this is a pretty long video, but we talked about generic classes, how to test them, how to write equals, toString, hash code, how to write the accessors, and there's more things you could do here, but we also talked about the before each annotation and how to test multiple objects across different methods. So this is a great way to get into if you're in C212. This is a good way to start on problem 5 on problem set 4. Okay, generic classes are really, really, really important. Okay, and in the next section, we will actually design our own array list implementation. Okay, so look forward to that.